Go.
A tank of water in the shape of a cone is leaking water at a constant rate of 2 feet cubed per hour. The base radius of the tank is 5 feet and the height of the tank is 14 feet. Question A. At what rate is the depth of the water in the tank changing when the depth of the water is 6 feet? So to start off this problem, we're going to start with a quick sketch of the 3D tank, but the sketches will be in 2D in order to view it better, I guess. So the tank is in the shape of a cone. So we'll make a cone first. The radius of the tank is 5 feet, and the height of the tank is 14 feet. So the radius of the tank, so from here out, will be 5 feet, right there. And the height of the tank is 14 feet. 14 feet. All the way down to the tip. So, now we know that at what rate is the depth of the water in the tank changing when the depth of the water is 6 feet. So the radius, we'll split this cone up into triangles. The radius will be the height of the height right here will be 6 feet. And that's what we know. And we're trying to find the depth of the water when it's 6 feet. The rate of the depth of the water when it's 6 feet. So the volume of this is going to equal 1/3 pi r squared times the height. And we also are given that the volume prime is equal to negative 2 feet cubed per hour. And we want to find the h prime when h is equal to 6. So the first thing that we have to do is find the differentials with respect to time. And we are able to do that, so we have to find r and the differential of r and the differential of h. So to do that, we have to find dr over dt, and that is equal to 2 times 1/3 pi r 2 minus 1 times dr over dt times h, and dh over dt, which is going to be equal to 1/3 pi r squared times dh over dt. And then we have to add these two together to get the v prime with respect to time. So that was going to equal v prime is equal to 2/3, so we'll start with the top one, 2/3 pi r times dr over dt h plus 1/3 pi r squared times dh over dt. So now we know v prime, which is negative 2, and h, which is 6. And we want to find h prime, and we don't know r and r prime. So we also have the ratio of r over h is equal to 5 over 14. And we can multiply h to get r is equal to 5 over 14 times h. So now we're able to plug this into r into the original equation. And so that we are able to find v is equal to 1/3 prime r squared h. So now we plug in r, which we can equal to 1/3 pi 5 over 14 times h squared times h, which is going to equal 25 over 588 pi, remember we still had pi in there, times h cubed. So now that we have this, we're able to take this excuse me, and plug this into our v prime equation, which is going to equal v prime is equal to 25 over 196 pi h squared times h prime. So now that we have this equation, we know that v prime is equal to -2 and h is equal to 6. So we will plug these in. So -2 is equal to 25 over 196 pi 6 squared times h prime. So we solve for h prime and we find that h prime is equal to negative 0.1386 feet per hour. So we have found the rate at which the depth of the water in the tank is changing when the depth of the water is at 6 feet.
So now we're going to be taking a look at question B. At what rate is the radius of the top of the water in the tank changing when the depth of the water is 6 feet? And so we're going to be using a lot of what we did in question A to help us do question B. And so first we're going to be taking a look at that relationship in the original problem. And so we know that h over r equals 14 over 5. And from that we can gain h equals 14 over 5 r. And so now we need to get the volume in terms of v and r and then proceed as before. And so that's not terribly difficult. And so we have r equals 5 over 14h. And so that just means that r prime equals 5 over 14, 5 over 14 h prime. And so as we can see, if we take the relationship that relates r and h that we used in the first part and differentiate it, we get a relationship between r prime and h prime. And at this point, all we need to do here is use the results from the first part to get r prime equals 5 over 14. And we get this part now from the first part, 98 over 225 pi. And that equals -7 over 45 pi, which in turn equals -0.4951. And so much easier than redoing all of the first part, but note, however, that we were only able to do this easier way because it was asked for r prime at the exact and the same time that we was asked for h prime in the first part. And so we didn't have to go through that long process. And so in turn, we find that the radius decreases at a rate of 0.04951 feet per hour. All right.
Literally just do it, and
Just
I'll
go.
read. I'll just
yeah,
read
just
this.
read it. Just read it.
All right. A tank of water in the shape of a cone is leaking water at a constant rate of 2 feet cubed per hour. The base radius of the tank is 5 feet, and the height of the tank is 14 feet. Question A. At what rate is the depth of the water in the tank changing when the depth of the water is 6 feet?
All right, so now we're going to be taking a look at question B. So it's at what rate is the radius of the top of the water in the tank changing when the depth of the water is 6 feet? And so we're going to be using a lot of what we did in part A to figure out part B. So what we're really doing is finding r prime first. So we're going to go back to that same relationship from the original diagram. So we know now that h over r equals 14 over 5. And so we're going to take that, and we're going to get h equals 14 over 5r. And so we're going to take this, and we're going to find the relationship by getting the volume, to get the volume in terms of